A company introduces a new production method for cutting steel rods. To test whether the new method produces shorter rods on average, 5 rods are cut using both the old and the new method. You may assume that the differences are normally distributed. Using a paired t-test and a 5% significance level, test whether the new method produces shorter rods on average. What we will do to begin with is enter in these data into the calculator. Let's go to the statistics application. Let's enter in the old data. We have 52, 55, 50, 53, 56. Let us enter in the new data into list 2. We have 51, 53, 48, 51, 54. We have the null hypothesis H0 where mu d equals 0, and we have the alternate hypothesis H1 where mu d is less than 0, and we have 5 pieces of data. Now, for us to calculate the test statistic, let us go to list 3, and in list 3 we will work out the differences between these. So, if I press variable, then the 5th option for list, we want to do list 2, subtract, and if we go back to variable, list 1. And if we execute, you see the differences are in list 3. If we go to the setup and then the 3rd option for hypothesis test, we have a t-test, 1 sample. The tail we have is a lower tail. We will select data from list 3. If we execute, you will see the test statistic is equal to -9. The number of degrees of freedom is equal to 5 subtract 1, which is 4. So now we can calculate the value of t with 4 degrees of freedom. Let's press the home key and go to the distribution application and go to student t. Here we have 4 degrees of freedom. We have 0.05. You will find t with 4 degrees of freedom to equal -2.131. If we now compare the -9 with the -2.131, we see -9 is less than -2.131. Therefore, there is sufficient evidence to reject H0 and conclude that the new method produces shorter rods. A sports scientist wants to test whether a new training program improves sprint performance, i.e. reduces sprint times. 5 athletes run 100 meters before and after completing the program. You may assume that the differences are normally distributed. Using a paired t-test and a 5% significance level, test whether the program reduces sprint times on average. Let us enter in the data into our calculator. Let's go to the statistics application. In list 1, we will enter in data before. We have 13.2. 12.9, 13.6, 14.0, 13.4. In list 2, we have the data after 12.8, 12.5, 13.1, 13.6, 13.0. We have the null hypothesis H0 where mu d equals 0, and we have the alternate hypothesis H1 where mu d is greater than 0. We have 5 pieces of data. We can work out the test statistic. In list 3, we will work out the differences. If I press variable, then the fifth option for list, we want to do list 2 subtract list 1. So we press variable, 5 for list, and the first option for list 1. You can see in list 3 we have the differences. If we go to the setup and then the third option for hypothesis test, we have a t-test, we have a one sample t-test. We select the appropriate tail. We will calculate data from list 3. You will see that we have the test statistic. Now, of course, we take the magnitude of the negative 21, which is 21 for our test statistic. We can work out the degree of freedom. That's equal to 5 subtract 1, which is 4. We can now calculate t with 4 degrees of freedom. If we go to the distribution application, we have a student t. Let's select the appropriate tail. We have 4 degrees of freedom. And we have a 5% level of significance. You can see t with 4 degrees of freedom is equal to 2.1318. We can now compare the 21 with the 2.1318. We see that 21 is greater than the 2.1318. Therefore, there is sufficient evidence to reject H0 and conclude that the training program reduces sprint times. A psychologist is investigating the effect of a mindfulness course on participants' stress levels. A random sample of 5 participants had their stress scores measured before and after completing the course. Higher scores indicate greater stress. You may assume that the differences are normally distributed. Using a paired t-test and a 5% significance level, test whether the mindfulness course has an effect on mean stress score. Let us begin by entering in the data into the calculator. Let's go to the statistics application. Here we will enter the before data. We have 28, 31, 27, 30, 29. In list 2, we will enter in the after data. We have 25, 28, 29, 26, 28. We have the null hypothesis H0 where mu d equals 0 and the alternate hypothesis H1 when μd does not equal 0. Here we have a two-tailed test. We have 5 pieces of data. In list 3, we will work out the differences. We have list 2, subtract list 1. You can see here we have the differences. Let us go to the setup. We have a hypothesis test. We have a t-test, one sample t-test. We have a two-tailed test. We will select data from list 3. And if we execute, you can see the test statistic is equal to -1.685, etc. Now, here we can use the positive version of this or the negative version. It doesn't make too much of a difference because we have a two-tailed test. The number of degrees of freedom we have is 5 subtract 1, which is 4. So let us work out the value of t with 4 degrees of freedom. Let's go to the distribution application. We have a student t, and for the tail, we will use the upper tail. We have 4 degrees of freedom. We look at the top 2.5% because we have a two-tailed test. You can see the value of t is equal to 2.7764. Now, if we compare the 1.685, etc. with the 2.7764, we see that the 1.685, etc. is less than 2.7764. Therefore, there is insufficient evidence to reject H0 and conclude that the mindfulness course changes mean stress scores.